So for the first part, what we have to do is, in this quadratic, we have 3x squared minus 6x plus 3. We have to find out the coordinate of the vertex. So just a quick summary of the vertex. Now, when you see the vertex is actually the minimum or the maximum point of the vertex as, I mean, of the quadratic graph. So this x coordinate of the function is given by, vertex is given by minus b over 2a, which is also the line of symmetry for the entire graph. And x equals to minus b over 2a, whether it opens upwards or downwards. Now, the graph will open upwards if the coefficient of x squared is positive. So a couple of like the prior knowledge stuff that we need to understand is the graph is going to open upwards. So if a is positive, the graph will be like this. And if a is negative, the graph is like here. Now, next up is how do you find out the exact coordinate of the vertex? So first thing is that let's take an example, this one, where we first finding out the x coordinate of vertex, which is negative b over 2a, which is going to be negative of negative 6 over 2 times 3, which is nothing but 6 over 6, that's 1. So the coordinate of x coordinate of vertex is nothing but 1. Now to get the y coordinate of vertex, and since we know that, okay, let's say this x coordinate we got is at 1, and to track the y coordinate, where is the y coordinate? You just plug in the main equation. So basically, f of 1 is the y coordinate of vertex. So in this case, you substitute this x out here, which is going to be 3 minus 6 plus 3, which results in 0. So your y coordinate of vertex is 0 as a result of the overall coordinate is vertex is at 1 comma 0. Now, when you describe this graph, you already get an idea with the coordinate of vertex and the coefficient of x squared. That okay, it's like a happy face graph because the graph cuts x-axis at, I mean, the vertex is at 1 comma 0. So this minimum point is at 1 comma 0. It means it is somewhere on the x-axis. But still we have to get the other features. And it is a happy face graph because the coefficient of x squared is positive. Now we have to still get the other stuff to be more sure what exactly does your graph look like. So y-intercept. Now for y-intercept, you plug x as 0. So when you plug x as 0, because at any point where the graph cuts y-axis, this coordinate is going to be 0. So x coordinate is 0. So if I plug x as 0, you get y coordinate as 3 because 0, 3 times 0 minus 6 times 0 plus 3. So it's going to be at 0 comma 3. So that's your y coordinate. Now talking about the x-intercept. X-intercept is where the graph cut x-axis. Now at x-axis means where it cuts x-axis means your y coordinate is 0. So what you do is basically you take 3x squared minus 6x plus 3 equals to 0 and you factor it out. And if you factor it out, you'll notice that it is x squared minus 2x plus 1 equals to 0. Because if you remove 3 common from here, I get something like this. And if you divide 3 other side, you get this equation. And if you factor it out, you'll notice that it is x minus 1, which is 0. And as a result, you get only one point where the graph is crossing x-axis, and that point is nothing but 1. Number 4, they are saying that find discriminant and hence prove that it crosses at only one point. There was further question. So already we got from here that there's only one x-intercept, but understanding the concept of discriminant is equally important. So when you say discriminant in the quadratic formula, we have b squared minus 4ac. This is the quadratic formula, and this part is referred as discriminant. So if b squared minus 4ac is equals to 0, it means that the graph touches x-axis, or you can say there's only one root or one point where the graph crosses x-axis. So it'll be something like here. Now, if your discriminant is more than 0, so if graph cuts at, like, if your discriminant is positive, it means the graph is going to cut x-axis at 2 distinct points, like this, or it can be like this. So here, in this case, discriminant will be higher than 0 because you have 2 distinct roots. Now, in the third case, where the graph is entirely above x-axis or entirely below x-axis, so in that case, your discriminant will be negative. So this is just a summary of what we need, but in our context, since they have said that it crosses at only one point, our discriminant must come to 0. That's what we need to prove. So let us find out the discriminant value here. So when I do b squared minus 4ac, which is negative 6 the whole squared, minus 4 times 3 times 3. So a value is 3, b is minus 6, and c is 3. So 36 minus 36, which is 0. That proves that the quadratic is either tangent to x-axis, or you can say one root, or it basically meets the x-axis at one point. So that's the proof of this. Now the final part is sketch the graph and predict the domain and range. Now with all the information that we have got, we have to sketch the final graph. So now I'm just going to draw the final graph out here. So number one is the vertex. Vertex at 1, 0. Now, because it is the minimum point, because here the coefficient x squared is positive, so this is already the minimum point. So the graph is not coming below x-axis. And anyway, it has got only one root, which is at also 1, 0. You can see clearly that this is at 1, 0. Now, y-intercept is at 0, 3. So the graph cuts y-axis at 0, 3. Now, when you look at the final graph, it will be happy face graph. It will be like passing like this. So this is your final sketch when you graph. Now, final coming to domain and range. Now, this is a polynomial function, or any general polynomial, you can input any x value you want. So if I input any x value, particularly here, x will be greater, x can be any real number, but your y will be greater than or equals to 0. So y is actually minimum at x equals to 1, and that's where range is y higher than or equals to 0.